Hello everyone, welcome to my YouTube channel. So today my presentation is about maths in architectures. Maths is all around us and it is almost impossible to think something that's made without the help of mathematics. Architects use maths for several reasons. Architects mainly use mathematics like algebra, calculus, geometry and trigonometry. They also use mathematics to design forms that are considered beautiful or harmonious. So first let's see how architects use golden ratio. Golden ratio is an irrational number that is approximately equal to 1.618 and it is denoted by pi. That pi exists in a line segment when a plus b is divided by the longest segment a. You can get a clear idea if you look at this golden rectangle. If you take the line segment containing 3 and 2, 3 plus 2 is 5. So 5 divided by the longest segment 3 gives the golden ratio. Similarly, if you take the line segment containing 5 and 8, 5 plus 8 is 13. So 13 divided by the longest segment 8 gives the golden ratio. In this picture, the first one is ancient Greek architecture Parthenon and the next one is Taj Mahal. Ancient Greek architecture used golden ratio to determine the relationship between the width of a building and its height. The presence of golden ratio provides a sense of balance and equilibrium. So now let's see how they used golden ratio in Egyptian pyramids. We know pi is 1.618. By adding 1 to it, we get the square of the pi 2.618. That is pi plus 1 gives pi square. Actually, it is a special case in mathematics. Then by using Pythagoras theorem, they constructed the golden triangle of sides root pi, 1 and pi. Bridges and their structures. So now let's see what are the mathematical principles behind bridges construction. Actually, there are so many types of bridges. I'm going to explain max behind two bridges today. So first one is truss bridge, a bridge which is constructed with the help of triangles. So triangles are used in bridges because they evenly distribute weight without changing their proportions. If they used a rectangle in its place, the bridge would collapse and flatten out. So next one is Brooklyn Bridge. Actually, it is a type of suspension bridge. Suspension bridges are stable when the horizontal and the vertical forces acting on its main cable are in equilibrium. The equilibrium occurs when the main cables are in the shape of parabola because the parabola distributes forces of the heavier parts to the ground. So next is Indian architecture. When it comes to Indian architecture, Indian widely used geometry and mathematical shapes in construction. So first one is Pragadishwara temple. In this isosceles triangle is formed when we join Vimana and the extreme points of the main temple. It provides a steady foundation and can withstand tremendous pressure. So next one is Srirangam Raja Gopuram. The Gopuram of the temple is more or less like a trapezium. Trapezoid is stronger than rectangle. Next one is Konark Sun Temple. If you look at this picture, you can find that there are so many geometrical shapes like triangle, trapezium, square, rectangle and lines. So there are so many geometrical shapes are used. So Pythagoras theorem. We know that Pythagoras theorem is the square of the hypotenuse is equal to sum of the squares of the other two sides. Indian architects used the Pythagoras theorem to calculate the right angles to build roofs, walls, sidewalks, and to calculate unknown dimensions. So these are the few examples of how the Indian architectures used the Pythagoras theorem. So first one is Jaipur Palace and second one is Mysore Palace. Taj Mahal. The Taj Mahal is perfectly symmetrical. Its pillars, walls, rooms and even garden follow a perfect symmetry. So the symmetrical shape providing beauty to Taj Mahal. The four minarets surrounding the Taj Mahal were constructed further away from the main structure than usual. The minarets also lean slightly outward rather than stand straight. This is why actually it was done as a safety measure so that if any one of them fell, They would fall away from the dome rather than crash into the central structure. These are the few other examples of how architects used symmetry in architecture. Next, examples for proportions in architecture, and these are the examples for how they use the angles in architecture. So architects use most complicated type of maths to master designs. Technology may be rapidly advancing each year, but the mathematical principles behind architecture ever remain the same for centuries. So without mathematics, bridges would collapse, skyscrapers wouldn't exist, and building would be rocky and unshaped. Thanks for watching this video.